Okay, problem number 3 of the test 5 review. If an old battery of electromotive force 3 volts, EMF 3 volts, has an internal resistance of 1.7 ohms and you connect it to an external resistor of 15 ohms, what will the terminal voltage across the battery be and the current in the circuit? Okay, so this is a battery theory and what's known typically as electromotive force theory. So a battery is a source of electromotive force, and to draw the battery in general, we draw like this symbol. This is the EMF of the battery, and then the battery has an internal resistance, and then you connect it with some circuit, and this is called the external resistance. This is called R internal. Okay, all batteries, when you first buy them, the internal resistance is going to be approximately 0, right? So all batteries have some kind of internal resistance. It's a function of the use of the battery, how long it's been used, the rust that has collected inside, and all of the other things through use and stuff. The internal resistance of the battery rises, right? And it cannot function to the same level of ability that it could when you first bought it, right? The electromotive force, the EMF of the battery, is what it's intended to give you, right? So when you buy a 3-volt battery, a 1.5-volt battery, a 9-volt battery, that's its EMF, right? So in this case, the EMF is 3 volts. It's intended to give you 3 volts if the internal resistance is 0, right? So what's going to be the current in this circuit now? Now it's told us here that over time the internal resistance has risen to 1.7 ohms, right? This is the symbol for ohm. The external resistor that you are connecting it to is equal to 15 ohms. 15 ohms, right? So the two resistors will act in series. So it's basically like adding 1.7 and 15, right? So then the total resistance of the circuit is going to be 1.7 plus 15. It's going to be 16.7 ohms, right? So now, what's the current in the circuit? The current in the circuit is the intended voltage of the battery, the EMF, divided by the total resistance of the circuit. It's going to be 3 volts divided by 16.7. Let's see what this gives you. So basically, for this kind of problem, we first have to solve what's the current in the circuit. Then we'll go back and explain what is terminal voltage, and then we'll solve for that. 964 amps is the current in the circuit, right? So now, what is terminal voltage? This term, terminal voltage, right? Well, the terminal voltage is the actual voltage that the battery is supplying in that circuit, right? In other words, it's the total voltage from here to here. It's the whole thing. So as you go from the negative to the positive of the battery's own internal EMF, you gain 3 volts, but you're going to lose some voltage through the resistor, right? Because there's current going through it. So the terminal voltage, VT, is the EMF of a battery minus how much voltage do you lose through the internal resistance of the battery? It's equal to IR int. The voltage in a resistor is always the current through the resistor and times the resistance of the resistor, right? So there's a current flowing through here, and the current is equal to 0.17964. If you multiply that times the internal resistance, that tells you how much voltage you lose. So the terminal voltage 3 minus 0.17964 times the internal resistance is 1.7. So 1.7, so if you multiply this current times that, .305. This one here is going to be 0.305 volts. So because of the internal resistance of the battery, which is due to the use of the battery over time, you are actually losing 0.305 volts inside of the battery, right? So what's the battery actually giving you? V terminal 3 minus 0.305, 2.695 volts. So the terminal voltage of the battery is 2.695 volts. So the battery is not giving you exactly what it's intended to give you. What would happen if you had connected it to an external resistance of, let's say, 1.5 ohms? Much less, 10 times less ohms. So its own internal resistance 1.7, you connected it to a 1.5. How would things change now? Well, now the total resistance would be 1.7 plus 1.5, and then the total resistance would be 3.2, and then what would happen to the current? 3.2. Oh, so because the total resistance is less, now the current is higher, right? 3 divided by 3.2, 0.9375 amps. So the less the resistance you connect to, the more the current in the circuit, which makes sense. Now what's the terminal voltage? The terminal is EMF minus IR int. So we're going to have 3 volts minus 0.9375 times the internal resistance is going to be what? Well, that's going to be the same. That hasn't changed. 1.7. So the only thing that happened as a result of connecting it to a smaller resistor is that the current is higher, and now you're going to lose more voltage in the battery. So 1.7 times 0.9375, 1.59 volts is lost. So 3 minus that, 1.4. So the terminal voltage is 1.406 volts. So what happened? What can we learn from this? If you connect an old battery to less resistor, the old battery, you can really tell that the old battery is old, basically, right? Because it cannot deliver what its intended voltage is. Its EMF is 3 volts, it can only deliver 1.4, right? If you connect it to a 15 ohm, 2.69, you can't really tell that it's old, right? So the bigger the resistor you connect to, the more it can still function as a regular battery, right? What if you connect it to a resistance of 150 ohms, right? Well, if you connect it to 150 ohms, the current's going to be much less. The voltage lost inside the battery is going to be much less, and the terminal voltage of the battery is going to be much closer to 3 volts, right? Of course, we're assuming here that the internal resistance stays 1.7 ohms. Over the course of time, the internal resistance might become 10 ohms, might become 50 ohms, and might become more and more bigger. Obviously, there's going to become a time when the battery is no longer usable, right? But if it is still usable, it's better to connect the battery to a bigger resistor so that the battery can function more like what it's intended to. Okay, so now you know how to approach these kind of problems. Thank you very much.